Okay, so I've got my T-joints together right now and we're gonna do some welding. Small little adjustments can give you big results. So what we wanna do today is we wanna have a look at some of those common mistakes when MIG welding. We're gonna break this up into two categories. One being sort of the physical side of things. You know, that's like your travel speed, your stick out, things like that. And then we're gonna look at settings at your voltage and your wire feed speed. So let's get going.
I wanna start with a good weld with little to no defects. That'll give us a benchmark to make reference to. Today we're welding on Miller's Multimatic 255 multi-process machine. We're welding at about 19 volts and just under 300 wire feed speed for this machine. That seems to work really well. And we're using 3/16 material, carbon steel. Let's pay attention to that short circuit transfer, how smooth it is. Some people say it sounds like bacon frying. I don't know about that. The important thing is that it's nice and uniform. All right, point and shoot with this start. I'm establishing that puddle. I'm staying at the leading edge and I'm washing into those sides. I'm doing a little oscillation side to side, keeping that bead nice and uniform, nice and crisp. I don't see any unwanted spatter or any huge hiccups. This is a good travel speed. Once again, I'm staying at the leading edge. I'm not letting that puddle get ahead of me on this. All right, we're gonna use this one as our benchmark. MIG is pretty fun because once you've got your settings dialed in, you can put some pretty nice welds down. So I don't have a whole bunch of unwanted spatter. That little bit of spatter that you're seeing can come off easily with the wire wheel, and that weld is relatively flat. So we wanna be flat to slightly convex on this.
Okay, so now that we know what a good weld looks like, let's have a look at some of those physical aspects, such as your stick out being too long, your travel speed too fast or too slow, and then having dirty material, of course. So the first item we're gonna have a look at is your stick out. Now remember, the stick out is the measurement from the end of the contact tip to the tip of the wire. So make sure we keep that measurement there and not from, sometimes we go from the nozzle to the end of the wire because that's what we're seeing. Sometimes that tip is recessed inside that nozzle.
All right, and this one, my stick out's way too long. It almost looks like I'm going in cold. That weld is super sluggish. It's really slow. It doesn't sound proper. Even though I've got the right settings, having that stick out too long is gonna produce an undesirable weld. Eventually, I'm gonna have some cold lap, lose gas coverage, which eventually will cause porosity. But obviously, this thing did not turn out well. So you can see by all that extra smoke, you got extra spatter in there. You've got porosity. That's the gas coverage that wasn't doing its job. You've got a bunch of lack of fusion. You got some cold lap in there. Yeah, this thing's nonsense, no good. We're moving on. On this one, my stick out's way too close. Here you can see that my nozzle is so close that it's eventually gonna drag in my puddle. It creates poor visibility and it spikes your voltage. Having your stick out shorter will actually increase the voltage, causing your puddle to be too fluid and eventually undercutting that plate. Even though this weld doesn't look half bad, you can tell that it's oversized and that top is undercut. Now I'm cutting over to another shot where I'm just welding in the flat and you can see where my nozzle is actually dragging in that puddle. Now whenever we have a look at the finished product, you can see those little marks. So this is super common. Some people don't recognize this until they're done welding. And if it's a job that calls for a nice cosmetic appeal, well, that'll have to be ground out.
All right, now that we're done that physical side of things, let's have a look at settings, which is, your wire feed speed and your voltage. So for the most part, if you're starting out, you don't know what the heck you're doing. You're just gonna go in there, you're gonna set your machine maybe to the manufacturer's recommendations. Maybe you come in and you see that your bead is a little bit too humped up. And is what we wanna do is we increase the voltage because that's gonna flatten out your bead, right? Well, sometimes we do that, we overshoot the mark. And what happens is you increase the arc length too much, which decreases penetration. So I got a prime example here of what happened, and that's exactly what somebody did. I got this piece of material here that just slides right off, and that's because there was a complete lack of fusion on this plate. So without actually understanding the relationship between voltage and wire feed speed, you could actually be doing yourself harm if you increase that voltage too much. Now, this can actually happen from a number of reasons. You could have too large of a stick out, you could have too much wire, right? You could have too little voltage. So there's a number of reasons, and we're gonna look at them right now.
Let's have a look at how that machine behaves when we have too much wire, how it sounds, and what kind of weld it produces. You can kind of hear the spittering and spattering, and it almost feels like the weld wants to push my wire away or my gun away. And that's because there's not enough voltage to melt off that excess wire. So that wire has to go somewhere, and eventually it just sort of splashes along the plate. Oh boy, let's have a look at this one. I don't know what I'd give this welder. Maybe about $1.50. I think this one's pretty self-explanatory, but it has every defect under the sun. All right, in this one here, we don't have enough wire. And you can hear this like hissing sound, and that wire wants to burn back into the tip. So that's an indication right there that you've got too much voltage or not enough wire. Is what happens is that arc length increases and it wants to burn back into that tip. All right, once again, you can see here that finished product. There's an excess amount of smoke on here. You can actually see undercut, and that's because that arc length is too long. That material is being cut away, but not adding any filler metal to it. So this is always interesting. This was my honest attempt to do a restart, and I hit a chunk of silica and it actually pushed my plate back a little. So let's make sure we knock off that silica when we're doing a tie-in or when you're doing multi-pass welds. It's just going to get in your way. It can cause a lack of fusion. And as you can see, it can cause you to sort of, push back on your plate and not arc when you need it to.
All right. Did this next video ever go bad? Like, I'm pretty happy we're done with this one here. It was just super smoky, super dirty. You don't want to be sucking that shit in. No good. Let's have a look.
So this might actually be the rustiest piece of metal in North America. So as we lit up, as we started welding this, you can see all that terrible smoke. Now, this is an extreme example of not having a clean weld, but you can see where this can go. If you don't clean your material properly, especially with that MIG, that wire is only going to go so far. It does have deoxidizers in it, but make sure we clean our plate. Now, believe it or not, these were appropriate settings for welding this thickness of material, but there was just so much rust that it was preventing it from penetrating, from fusing into that plate, and caused a whole bunch of cold lap. Now, you can actually see all the impurities in that weld. In this one here, I'm traveling way too fast. You can see me motoring along that plate here. It's actually not fusing into those sides or washing into those sides nicely. So a good indication that you're traveling too fast is when your puddle is actually chasing your wire, kind of like snaky looking. Now you can see here in our finished product exactly what I was saying. We're not washed into those sidewalls. Our weld is pretty thin and pretty snaky looking and just too fast. On this one here, I'm traveling too slow. You can see that puddle starting to get ahead of me a little bit. Now, a rule of thumb is to always be at the leading edge of that puddle, especially with short circuit MIG. Is what happens is that puddle freezes underneath, and the metal that we're putting on top is just getting deposited on top, causing lack of fusion. So you're not actually penetrating into that plate. You're just welding on top of previously deposited metal. In this finished product, you can see that I've overheated that plate. I've got a bit of cold lap, which could be an indication of lack of fusion. So this weld here was no good. Travel speed too slow. Let's take a second and recap. In this one here, we've got too much voltage. So you can kind of hear that weld, that short circuit kind of hissing back and wanting to burn back into the tip. So that's going to create too much smoke. It's going to cause a lack of penetration in some cases and just give you too flat of a weld and eventually undercutting that top edge. Another marker that you've got too much voltage is that your arc length is very long, and that's the distance from the end of the wire to your workpiece. So if that is oversized, and that would be a good indication that you've got too much voltage. And this last one has too much wire, so you can hear it spitting and spattering and kind of pushing your plate back. So this is where your arc length would be too short almost. Well, there's just not enough voltage to melt off that wire. So that's going to kind of leave you with a bunch of spatter, a bunch of cold wire all over your plate.
All right, folks, before we sign off, let's review a few things here. It's not the machine, it's not the Cayman gloves, it's not the helmet that's going to make you a better welder. It's the settings, it's how to use that piece of equipment properly and knowing what to look for whenever something is going wrong and applying that corrective action. A big part of this nozzle right here is shielding gas, and that gas has to come out. If you've got a dirty nozzle, if that is obstructed, those little holes are not going to deliver the proper amount of shielding gas. Your material, make sure you clean that mill scale off. That S wire, that S6 wire is designed to weld on slightly rusted material. Improve your chances. Clean that plate, get rid of some of that mill scale. Remember those angles. Go back to the beginning and think of those parameters, the travel speed, your angle, your stick out. All that stuff plays a huge part in producing a desirable weld bead.